Why should I choose a container over a full operating system? You know, in years of working in the world of operations and deployment, I've thought about the complexity that goes behind managing operating systems. And let me tell you, between storage, between all the patching, security, network intrusions, you name it, it's just a lot more work. If you're simply needing a runtime to have your application run, there's no need for you to run an entire operating system, manage a kernel, and ensure all those other extra packages are managed. Let's move beyond that. Let's simplify life. A container will just provide you with the runtime you may need, and then you can go ahead, add any additional dependencies, and then make sure your application runs. So it's about reducing how much work you as a developer or maybe an operations person have to do, and really improving how quickly you can work. So less mess, less fuss, and more creating. And that's really the big key. We say containers over maybe a full virtual machine because it's going to give you the added control, simplicity, and ultimately the ease of deployment for your application. Hey, it's Jay. Welcome back to AzureFunBytes. You know, that video of me seems like it was a million years ago. I know I look like a million different person since then. And hey, you know, we all have some change and growth. And that's kind of what everything's about nowadays. We all have to evolve. We have to change. We have to grow. And so that's what we're going to do, because we do that here every week on AzureFunBytes. We get together and we learn to grow ourselves and to build off the knowledge that we have and to increase it by discussing the products, the fundamentals, all the things that work alongside Azure to give you, the user, just an amazing experience. And so this week, I wanted to bring in someone who's done the show before to help me learn a little bit more about containers, Kubernetes, and different ways to manage my packages. And to do that, I'm bringing none other than Captain America himself. I love that shield, Donovan Brown. How you doing today?
How are you doing, man? Yeah, it was funny when I was watching that video. I was like, man, I remember when you recorded that, and a lot has changed. Congratulations on the transformation, man. It's awesome.
Thanks. Yeah, I mean, that was back in, I think, the end of 2019 when we were all at a big gathering for the people in our cloud advocacy and DevRel organization. And, you know, one of the things that we can talk about first, Donovan, is that you left our organization. You moved on, and while you're still part of the Microsoft family, obviously, and we're all thankful for that, you found a new role working in the CTO's office for Mark Rusinovich at Azure. Why don't you tell me a little bit about it?
Yeah, it was, I think it was just time for a change for me. I've been in cloud advocacy 3 or 4 years. I've been really successful building an awesome team of which you were a member as well. And I took some time off, and during my vacation, it just kind of hit me like, I think it's time for me to have a change. So I reached out to Mark Rusinovich, who I've known and respected, and Abel and I used to joke, we want to be the next Mark and Jeffrey Snover, right? That was our goal. So I said, hey, why don't I go ask someone that I respect a lot in the industry and at Microsoft what I should do? So I literally just asked him for advice. I'm like, hey, Mark, I want to have a big impact at Microsoft. I don't care if it's as a manager in IC. Do you have any advice? And instead of advice, he had a job for me. So that's how I ended up over here. It was just like, wow, I couldn't believe it. It was awesome.
That's one hell of a piece of advice. Let me tell you, I should send him an email and ask for some advice someday.
I was shocked too, man. It was awesome.
Yeah. So you and actually one of your real long-term, or I should say long-time partners in crime, Abel Wang. Abel went over into that office as well. I know you kind of work on some different things, but you're back under that same umbrella like you were in advocacy, and it's great to see. I know you two work well together.
Yeah, I've known him for 21 years, and it's a joke. If you've known us that long, you know it's not long. If I go somewhere, Abel will be with me within less than 6 months. It's been that way for 20 years, right? I bring him everywhere I go, and as soon as Mark had an availability for a TA, I'm like, I know the guy you need. Like, you don't need to search anymore. This guy is perfect. And when Abel interviewed, they just loved him. So yeah, I'm really excited that we're going to be working closer together again.
It's hard not to love Abel. He's really just one of the best people that I've worked with, and he's helped me a lot, helped me grow. And I think, you know, that's one of the things actually you're doing right now is you're helping different projects grow that are kind of born out of open source. And so I'm kind of curious, what have you kind of seen lately that's really, moving the needle that you really feel is important for people to kind of consider, especially in relation to using Azure?
Well, one of the things, though, as soon as I got to the team, they were all excited about this thing called Dapper. And of course, I didn't know what it was, so I had to go get ramped up on it. But the more I learned about it, I'm like, oh my goodness, like this is revolutionary. This is going to change the way people write microservices, because we're all familiar with microservices and how popular they are right now. And if you've ever tried to write one, you're very familiar with how difficult they are to actually run. The service itself is small and that's easy to write. But how do you do service-to-service invocation? How do you store state in a meaningful way? How do I bind to databases? How do I do secrets management? There's a lot of intricacies that have to happen, a lot of communications, and you don't want to have to deal with that. So people use things like Spring Boot, or they'll use Stilto. There's these other frameworks that require all this knowledge of other APIs to be able to do that kind of communication. And then Dapper created these things called building blocks and says, oh, don't worry about state management. We'll do that for you. Oh, don't worry about secrets management. We got you covered. Oh, you want to call another service? Don't worry about that. We'll do service discovery and service-to-service invocation. We'll do retries for you. So all the stuff that made microservices scary are now just an HTTP call.
Yeah, I got to do a Dapper session with Mark Fussell, and it was really great to see how the process of creating, managing, and working with microservices is really advanced, and it's improved, and it allows people who are using some of the technology we're going to be talking about today, Azure Kubernetes Service and Kubernetes in general. It helps really provide some safety gates, if you will, around creating and codifying what it is you need. And of course, there's CLIs and stuff like that really helps it out.
Yeah, and what I also liked about it was it took away all the minutia and all the boilerplate and all the code that we really don't want to write, right? And lets me focus on the code that actually delivers value for my customer, because value is one of my favorite words. When I define DevOps, I use the word value as the center of it. And when anything that I look at that allows me as a developer to deliver value and get rid of all the distractions for me, that's something that I want to work on. And Helm, what we're going to be talking about today, is one of those tools that allows me to focus on delivering value and not the inner workings of how do I deploy something inside of Kubernetes, and which can be very daunting and intimidating. We all realize that we want Kubernetes, we just don't want Kubernetes, right? We don't want to know about it, we don't want to have to touch it, but we know we need the power and the flexibility that Kubernetes gets us. But as much as you can, please don't let me know there's Kubernetes back there, right? And I think tools like Helm and Dapper are going to allow you to deliver value and not worry about the infrastructure upon which you're running. And we're going to try to abstract that away from you as much as we can.
Yeah, I've found that great tooling abstracts as much from the original target. That was one of the big things about infrastructure as code, is that it was an abstraction layer. It said to you, don't worry so much about the underlying systems that you're working with. Just write it out as code and watch them come together to converge to be able to create what it is you actually need to do, as opposed to worrying about the things that go around.
Yeah, and the fact that it's declarative, I think, is extremely important, right? It's not just write it down and put it in source control, but just declare what you want. Don't worry about the timing. Don't worry about the dependencies, like what has to happen first. You just declare what you want. I'll take care of making sure that all the dependencies are resolved, that the resources are deployed in the correct order, that they're connected the way they're supposed to be connected, and that if you run this again, I won't break anything, right? Because when you're writing imperative code that has to go step by step and test, like, it makes it much more difficult. Just saying, make it so with a declarative type of language like ARM or Bicep or Terraform, it takes infrastructure as code, because infrastructure as code is different than infrastructure automation. Like, infrastructure automation is a little bit trickier. Infrastructure as code is that holy grail nirvana of that's what I want, go make that happen. And I totally agree. Again, it allows me to focus on delivering the value and not how do I implement and provision my infrastructure, for example.
Very cool. So Donovan, I wanted to let everybody know, because we do this every week, is that we have a poll. Okay. And we always try to find out a little bit about what the viewers are doing. And so there's two big ways for our viewers to take part in the conversation. One, take the poll, head over to aka.ms/learntv, especially if you're on one of the other channels like YouTube or Twitch, head over there if you want to answer this poll. And also, we've got this section where you can check out the show notes for today. That'll be in the blog post, of course. And then you can send in your questions. And if you're using your native broadcaster like YouTube or Twitch, feel free. You can send in those questions there. I'd love to hear from you. And I wanted to also remind everybody that a lot of the things that we'll be talking about, you can start working on Microsoft Learn. It's a great platform that you can use to begin your education into the different services in Azure, or even just the Azure fundamentals. There's a great training learning path right here, the Introduction to Azure Fundamentals. And so you can use the sandbox to try out in deploying all these things. I know that this Helm one is pretty new, and it looks really great, Donovan. I'm super excited actually to kind of get into that particular one myself.
Cool.
So I want to kind of get started. And so today's subject is, of course, Helm. And if you want to get to the Helm website, you can go to helm.sh. That's where you can take a look at all the different big pieces of Helm. And also make sure you check out this video. It's by Donovan. It's a longer form video about demystifying Helm. So whatever we may not cover here today, I'm sure that he's got it in that video.
Yeah.
So Donovan, why don't you tell me a little bit about how Helm and why Helm, and how you actually, started deciding this was the thing you wanted to work on?
Oh, cool. So when you start working with Kubernetes, you get very familiar with kube controller, kubectl, however you want to say it. It's a command line tool where you basically provide it YAML files that will allow you to then deploy those different types of objects inside of your Kubernetes cluster, be it a config map or a pod or a secret, whatever the case might be. But you're spending a lot of time at the command line. And depending on how many objects you want to store inside of Kubernetes, you might be running kubectl apply a lot. What I find is funny is when you realize you screwed up, you type kubectl delete really fast, trying to remove all these bits and pieces out of there. And sometimes it can be problematic because they were all put in individually, and then you got to remember everywhere you were to go kind of get your cluster back to a place where it's clean or reset. And especially for a person that does a lot of demos like me, often I want to put things in and then I want to take it back out and put me back at time zero. And I got tired of trying to script in a way that just felt very foreign for me to be able to apply all those things and then pull them back out. So I was constantly looking for, how can I find a tool that will apply all of my YAML files for me and then give me a way to uninstall them and remove them all with a single command. That was my goal. So I started doing some research, and it led me to the Helm website. But I was thrown off by the slogan. It says, Helm is the package manager for Kubernetes. And I read that and I immediately thought, well, I don't think I need that, right? Because package management to me is NuGet and NPM. I'm thinking, yeah, I don't need to add additional stuff to Kubernetes. I just need to add my own app to Kubernetes. So I left this site and went looking other places, kept doing some more research. I'm like, no, I think this is what I want. But that slogan is really not putting me in the right headspace. What I want is not to install third-party packages, but to install my own application inside of it. Lo and behold, that is what Helm actually will do for you, right? Despite the slogan is like, no, if you give us all your YAML files, Donovan, we'll go ahead and deploy them for you as a unit and pull them back. And on top of that, allow you to override different types of values so that they're not all hard-coded files, which is where the real power starts to come in, is where I can parameterize the actual YAML file. And then at runtime, change the value from my dev environment to my QA environment or my production environment. Be able to pass from the command line secrets into there that I don't want to check into source control. We were just talking about infrastructure as code. It's a fantastic best practice, but never check in your connection string or never check in a path into source control. That's a bad thing. And Helm allows me to be able to segment the information that's safe to put in source control and then stuff that I need to stay outside of source control inside of Key Vault or some other type of secret store that I can apply at runtime and deploy. So I figured that out, and I downloaded a template like everyone does. And the template was so intimidating, right? When you see the notes file for the first time, or you see a chart for the first time that's been completely parameterized, it's really intimidating to look at. And I was like, man, I think this is what I need. And I fumbled around and I got it to work. And then months would go by before I needed it again. And then all of a sudden, you get this jarring experience again of, oh my God, I don't know what all these files do. I got it to work, but I really couldn't tell you why it worked or maybe even repeat this. So fast forward to me being on the new team, right? So I'm on the new team, and I find myself, we do a lot of things with Kubernetes on the Kubernetes team. Everything that we're focused on is cloud native, right? So I'm spending a lot of time in Kubernetes. I'm deploying a lot. I'm like, Donovan, you got to get to know Helm. And again, it was that intimidation of like, this is it. This is ridiculous. I don't want to go through this again. I need to stop using Helm, and I need to finally learn Helm, right? And to me, those are two drastically different things. Just using a tool every once in a while is not truly learning and understanding why the tool works. So what I did, and what I want to share with you today, is the exploration that I took to actually learn what Helm actually does, so that the next time I see a chart, I'm not intimidated by it. So what I did is I literally started from an empty folder. And I said, I'm going to add every file and every character one by one until I understand and can explain to others why Helm works, how Helm works, and when it's beneficial. So that's kind of how I got there.
And you mentioned like there's a big difference between just learning and using. And this right here, the GitHub repo, the community repo, and you can find it here on github.com/helm/community. It's an open source project. It requires other people to learn it in order for it to actually progress, to advance. And so I feel like that's a huge part. It's really been great to see how a lot of these CNCF projects have graduated and have become, first class options. When I first started hearing people talk about Helm during like Helm and Helm 2, it was a thing that some companies would, vendors would actually, say, well, here's a Helm chart also. Or people would develop their own Helm charts for specific package processes. But once Helm 3 came out and it really became visible to people that Helm was a first class choice for your package management for Kubernetes, I started seeing it get adopted more and more. And so I think that that's a huge part, is people taking part in the creation and advancement of Helm. And then obviously big vendors looking at it as an obvious place to work.
Yeah, and as it matured, they got rid of some of the friction that there was involved. Like you used to have tiller running inside of your Kubernetes cluster, so you'd have to do a Helm init. You don't have to do any of that anymore, right? So there's no burden or additional load running inside of your Kubernetes cluster to start using Helm 3, which I thought was pretty cool as well. Because I remember having to put in my pipelines the Helm init and make sure that the Helm init would succeed even if it was already initialized and things like that, which now you don't even have to do, right? You just do Helm install and it's just going to work.
Yes. So I wanted everyone to see this really cool comment that just came in, and it's from Marcelo. He watches it all the time. And so one of the things he brought up is your definition of DevOps. And DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Thank you always, Marcelo, for paying attention, watching, and letting us know. But so, Donovan, I want you to tell me about how we get value delivered from another tool that just will help us with our DevOps process, and that's Helm.
Yep.
So why don't I bring up your screen and kind of let you kind of start going through some stuff?
Absolutely. So what you're looking at is just Visual Studio Code. If you want to follow along, you're just going to need an editor. It doesn't have to be Visual Studio Code. You're going to need a Kubernetes cluster, which could be Docker for desktop if you want, which is perfectly fine with Kubernetes enabled, or you could have an AKS cluster. But actually what's interesting is the way that I learned it, we actually don't deploy anything. We're going to run through mock deployments, and I'll show you how to do that. And it'll tell me everything that was going to happen. But again, let's get down to the fundamentals. Was I needed to learn Helm and not use Helm. So I wanted to learn. My first question was, what is the minimum that I need to define a chart? Because a chart is the term that uses basically the packaging of all of the YAML files I want to deploy, and I can actually install a chart into my Kubernetes cluster. So what I'm doing here on my desktop is I'm in an empty folder. So if I were to do an ls right now, you can see there's absolutely nothing in the folder. Now there's actually a Helm command called Helm show chart. And what this will do is it'll say, I'll show you everything I know about the chart that you're currently in. I can either provide it a chart name, or the period or the dot says the chart is in this folder that I'm in right now. And when I run it, it says, hey, there's not a chart here. You need a minimum of something called a chart.yaml file. It's like, okay, no problem. So I'm going to create this chart.yaml file, and then I simply run the command again. It says, all right, great. You have a chart.yaml, but there's no name inside of this particular file. So if I go ahead and open up this chart.yaml file and I add a name to it, and I save it. And I literally just rinse and repeated this process. All right, great. I have a name in there. Let me go run this again and see if I get any further. And what it tells me now is that, okay, you are missing a version. So great, let's go back up here again. And that's what I was trying to do, is like, how do I learn how to do this step by step? And I just kept on going, and then boom, look at that. We have a chart. I was like, that's interesting. Whenever I downloaded a chart, it was full of different files and underscore helper TPL files and chart folders and template folders and notes files. Why is all that stuff there if what I have right now with a single file is an actual chart? And I started thinking that there's some weird stuff going on here, because if you look at my screen, what I thought was really interesting is that I didn't add this here, right? This thing here says that there's an API version. Well, I didn't add an API version, but there's an API version there. And it got me thinking that I wonder if there's more to a chart.yaml file than I'm aware of, because that seems odd that it added bits to it. There happens to be something called Helm lint. So if you're a developer, you've probably heard of a linter. And a linter will basically just read your code for you and give you hints on, like, yeah, you probably want to change that, or that doesn't look right. It's a form of
syntax correction.
Exactly. Static code analysis is another term that we used to use for things like this. Well, it just so happens that Helm has a linter that comes with it. And if I run Helm lint, I get a lot more information. Yeah, Donovan, you have a chart here, but this chart really could use a lot of work, right? First of all, you need an API version. I find it interesting that it's an error that I don't have an API version, but when I actually showed the chart, it defaulted one to it. Nevertheless, let's go ahead and fix that. So what I'm going to do is I'm going to come up here, and I'm going to add an API version. I'll just go ahead and stick 2, because it says you can be 1 or 2. It also aired out on me saying, hey, it looks like that you have a string for your version, but it shouldn't be. It needs to be. I mean, it looks like a number, but it needs to be a string. They use semantic versioning for these charts, and semantic versioning is a 3-part version where you have your major, minor, and your patch version. So there needs to be 3 parts, and as you can see here, there's only 1 part. So I'm going to go ahead and do 0.1.0. If you want to know more about semantic versioning, I actually have an entire video on my YouTube channel about what these numbers mean and what the rules are for when you increment one or the other, which is kind of interesting, because when I realized that this needed to be semantic versioning, I wanted to know everything there was to know about semantic versioning. It's actually a much deeper topic than I thought it was, which is kind of interesting. But
I'll see if I can find that video and and share for everybody.
Yep, because you'd be surprised. Like it's a pretty powerful versioning system once you understand why the numbers change. It also made me far more comfortable as a consumer of packages, knowing that, oh, okay, they only changed the last digit. That just means it's a bug fix. Then I'm definitely going to take that, versus they changed the middle number or the first number, which is like, okay, this could actually potentially break me. I need to go ahead and be a little more careful when I go ahead and upgrade to a particular version. So when you understand what those numbers mean, you as a consumer of packages makes your life a lot easier. So just FYI on that.
Very cool.
So what else does it say we need? Since we also need to have an icon inside of here, right? So an icon is just a recommendation, but I want to have no more errors. So I add an icon, which is just a URL to some image somewhere that you want to be associated with this particular chart. So if I go ahead and save this now, and I run the linter again, we're making some progress here. It also says you should have a values.yaml file, which I'm going to go ahead and create, but I'm not going to use right away. But we will get to that file and talk about it. And the other thing it says is you should have a templates folder. So if I go ahead and create a values file, and then let's go ahead and make the templates directory. Now all of a sudden, if I run this, we have a perfectly created chart with all the functions that we need to have in that particular chart. So if we were to come over here, and you could see we have the templates folder, the chart, and the values.yaml file. Now, this chart can actually be installed right now. So what we're going to do is we're going to do a Helm install command. So what you do is you say, hey, Helm, I want you to install, and I want you to call this chart inside of Kubernetes, because I will be able to run like a Helm list command, the list of all my charts that have been deployed. So I'm just naming it. It doesn't have to match the name of the folder you're in. I'm just saying, call it my chart anyway. And the chart lives in this folder. That's what that dot means, is that the chart I want you to install and name of my chart in Kubernetes is in the folder that we're currently in. Now, the reason this isn't going to actually install anything is because I'm adding the dry run flag. The dry run flag says, tell me what you would do, but don't actually do it. It's like a what if you're familiar with PowerShell. I'll tell you what I would do if I ran, but I'm not actually going to run. And it just makes this process a lot faster so that we don't have to keep installing, uninstalling, or upgrading our deployments inside of Kubernetes. So this makes your inner loop very, very fast. The debug flag is just so that it spits out a little bit more information for me than it normally would. So if we look at this right now, we now actually have a fully functioning chart. It says, hey, Donovan, I would go in and I would deploy this particular chart for you, and nothing would actually happen, right? Because we haven't actually given it any templates to go ahead and actually deploy, but we have a fully functioning installable chart with only these files available to us, right? So that's why, okay, great. Now my brain was like, okay, now at least I know what the minimum thing is. Let me go see if I can make this chart actually deploy something meaningful. One of the simplest objects that you can store inside of Kubernetes is something called a config map. A config map is basically just a named object that inside of it has name value pairs or other types of information that you can pull out and use in other deployments or other parts of your Kubernetes cluster. So what we're going to do is we're going to create a config map inside of our chart for us, right? So let's go ahead and create a config map. So it's very important that I'm placing this file inside the templates folder. This is very important because what Helm does when I try to install it is it takes every file that is currently in the templates folder, with the exception of those that start with an underscore, which we'll talk about in a minute, and it runs them through this templating engine, which means when we start to tokenize this, it'll replace all those tokens for us. And then what it produces for us is the final YAML file that needs to be deployed inside of your Kubernetes cluster. Helm does all that magic for us. This is what I was talking about earlier, where I can pass in values and override values so that it's not a hard-coded YAML file, but a YAML file that I can actually modify as I move forward. So that's what we've done. We've now put a config map inside of that particular folder. So let's go.
You know what?
Go ahead.
I was just going to say, before we leave config map, we got someone who actually asked a question, and I was curious if you want to be able to touch on it. So I think they're asking about this in Helm 3 and about creating from a property file without doing an untar of a chart. Can you grab, I guess, values.yaml and add those custom values? I'm not really too sure what he means, but the question's there on the screen.
Config map from a property file without doing an untar of the chart, like passing it from outside with custom values.yaml. Custom values.yaml, I am going to show you how to do that.
Sure.
So we're going to use multiple of them. So you might be able to use the -f command, which we'll use in a moment. And if it doesn't answer your question, if you say, oh, that's exactly what I was asking, then ask it again for us and maybe give us a little bit more detail. We might be able to answer that specific question for you. But at one point here, I am going to add an additional file that's not values.yaml and override values in that file with the additional file that I'm going to provide. But we're definitely going to get there. So let's go ahead and create a config map. So a config map, it's just a normal object inside of Kubernetes. So it has an API version, a kind of the thing that you're creating, which in our case is a config map, and a name for that item, which has to be a lowercase, all value lowercase here. And then what I'm going to do is I'm going to add some data to it. So now there's a data section. I'm adding 3 messages. I'm going to add hello world, from, and then Donovan Brown. Now, if I save this, and we go back down here and we run this command again, we're now going to see that this chart's actually going to do something for us. So if I come here and run it again, now we're starting to cook with gas, right? Because if we look down here, we see that I'm actually deploying a config map, and that config map will contain these values. So if I were to install this inside of Kubernetes, I could then go kube control config list, and I would be able to see that this config map is inside of there. And if I drilled into it, see these 3 messages inside that config map. Now imagine you have a dozen config maps and you have services you want to deploy. You can now start putting all those items in that same templates folder, and with a single install command, install all the files that are now inside of your templates folder in one command. And then to uninstall them, it's just a simply Helm uninstall of the name of the release that you created, and all those files will automatically be removed. That is what I was looking for, and why I'm such a big fan of Helm is I create a lot of templates that define a solution or an application for me that I don't want to have to write kubectl or string them all together in one big giant YAML file to deploy and uninstall them, right? This is a much more manageable way for me to have multiple files that say these are for services, these are for deployments, these are for config maps, these are for secrets, and it's easier for me to maintain, but then I get the same benefit as if they were all in one big giant file.
Yeah, it kind of reminds me of what I worked with recently with one of my friends from Gremlin when we talked about installing via Helm, Gremlin's chaos engineering service on an AKS cluster, is that what we did was we're not concerning ourselves as much with the application that we were installing and working with, but we were using a Helm chart to be able to add additional services into that cluster so that we can, kind of create, and here's where we talked about more abstraction layers. Take that and place it into its own chart, because maybe we're in a situation where, I don't know, maybe in dev, we don't necessarily need that particular piece of software installed on our clusters. It could be just something that we make part of the production deployment. And so I like the thing about Helm is the fact that you can use that to almost like parameterize the different types of installations that you're going to do and the different versions that you may be working with.
Absolutely, because if you're deploying the exact same solution in multiple environments, chances are connection strings, passwords, and configs are going to be different from environment to environment. But other than that, the chart is exactly the same. I want to install the exact same images. I want to expose the exact same services, but I need certain bits of the data to be different. And instead of having to copy and paste 3 different versions of the exact same chart and just twiddle the bits that are different, you can now have one chart that is like, this is the main chart. And then I'm just going to pass in that configuration change and apply the exact same chart in all 3 environments, and which we're going to demonstrate here in just a second. So right now what we have is a really simple config map, but it's hard coded. This is going to dovetail right into what you were just talking about. We don't want these to be hard coded. We want these to be values that I can read from somewhere else and potentially overwrite. So now we're going to start leveraging that values file that they mentioned. They suggested that you should really create a values file. And what we're going to do now is we're going to use that values file and populate it. So let's go ahead and populate this. So what we're doing is we're basically saying the message 1, 2, and 3 that we originally had hard-coded inside of our chart, we now are going to move those values here and then come here and replace these with a nomenclature that allows us to say, hey, I want you to actually read these values from somewhere else. So let me break this down real quick. The dot, this period here, is actually an object. And on that object is a property called values. And then that basically reads all of the values. And this is just plain YAML file. So I can have lists and objects and all the other type of fundamental types that we have inside of YAML. I can actually define those here. And this values object gives me access to all of the things that I've defined inside the values file. So now I've simply said, I want you to use message 1, message 2, and message 3 in these locations. What's nice is if I save this and repeat our install command, the output is exactly the same, which means, okay, now I start to see how I can parameterize things and move them around, which is really, really nice. Now, let's start getting to what we were talking about, the fact that, hey, but what if I have values that I want to be slightly different depending on what environment that I'm in? So what I'm going to do here is I'm going to create a dev.yaml file, which I hope helps answer the gentleman's question, the person's question you asked a moment ago. So now what we're going to do is we're going to go ahead and open that dev.yaml file. And I'm going to replace message 2 with the word 2 instead of from. It's from in the values file here, but it's 2 in the dev file. And now what I have to do is run my command again, but I'm going to add a flag that says, run the exact same command, but I want to provide you an additional file that will contain some overridden values. So let's go ahead and run this again. And now we start to see some really cool stuff happening. So if you scroll up here, we're going to see that we have some supplied values that are here. And then we have this computed value here, which is the 2 that came from the other thing. And if we scroll down, what we're going to see is that our config map now says hello world to Donovan Brown instead of from Donovan Brown. It took data from the values file as the default and then overrode anything that was duplicated in the dev file and actually provided that information here for me as well. So now I'm starting to be able to take data and mix and match it together. This goes one step further, which is kind of cool, is I can simply do a set command. So this might be the way that you would set information that needs to be protected or comes from Key Vault or a secret store that you don't want to check into source control, but I want to be able to apply it. And as you can see here, we have AzureFunBytes being the last item that did not appear anywhere in our values.yaml file or our dev.yaml file. I provided that data from the command line, but it was then able to override that. And you can see up here at the top where it talks about how it was able to see all the user provided or supplied values and then the computed values for all of them. And those are what got applied to my actual chart down here at the bottom.
I think that could be really useful for tagging things with metadata based on specific versioning or environment.
Exactly. So that's exactly what I liked about that is the hierarchical way where the data is. I can go in my values.yaml file and put the values I'm going to use 90% of the time. I can then go back in and create a dev.yaml, qa.yaml, prod.yaml file that only changes the connection string potentially, that doesn't have anything sensitive in it. I can then check all these into source control and leverage these files throughout my pipeline. I can then go back in, thanks to the ability to using the set command, and set sensitive data inside of Key Vault, or inside, if you're using Azure DevOps, there's a way to put protected variables inside of your pipeline. And then you would be able to pass those into your Helm install command so that those are late bound to your actual deployment and then pushed into Kubernetes. So I love that hierarchy of the ability to set defaults, override them, and then even override them again should I need to.
Very cool. So Donovan, I want to just take a minute to remind everybody, we've got our poll up. We'd love you to take part. And so head over to aka.ms/learntv. Take our poll, and also reminder that if you've got questions, because we got like a little bit more than 20 minutes or so left to get to them, please go ahead and send them in. We want to know what it is you want to know about Helm. So Donovan, I'll let you keep going. Thanks for giving me a second.
Oh, no, absolutely. One of the other things that I thought was interesting was not only being able to replace the data when I needed it, but also be able to kind of clean or sanitize the data. For example, what if I wanted the first message to always be lowercase? There's functions that you can use, and I can just type the word lower here. And now what it says is I'm going to take whatever's on the left, I'm going to pass it to this function called lower, and what you're going to get is the result of that. And I also might want to say something like, I would like it to be a quoted string, which means I want to make sure that it's surrounded in quotes no matter what. Now, if I save this and I run this again, what we're going to notice is at the bottom here, we have hello world, which is now all lowercase, although it is provided, as we can see up here, as a uppercase string. It's now lowercase and put in quotes, which is pretty cool. So I can then start to massage the data that I get from an external source to make sure that it meets the criteria or the form that I want inside of my actual chart, which is kind of cool.
Very cool.
Yeah, the power is crazy, and there's like hundreds of different functions that you can use, right? There's a whole website. If you go, I'm going to take you to the docs, the last thing I do, and I'll show you where you can find some other links to where they talk about all the functions that you can actually use. And I'm going to show you here in just a second. You can write your own functions as well. Now, one thing I want to put out as a warning here is you can get yourself in a little bit of trouble. So make sure that you think about the order of operations. So I'm going to break something here really quickly. I'm going to say, hey, I want to use the truncate command as well. So the truncate command will reduce the number of characters that actually gets put out there. Let's go ahead and say I want to reduce this to 5. So I'm like, hey, great. Take hello world, lower it, quote it for me, and then truncate it to 5. But when I run this again, bad things happen. And can you guess why bad things are happening?
I can't. Why don't you tell me?
Well, the reason why is because I put a quote at the front.
So
and then I took off the last quote. So I basically have an unended string as message 1 right now.
So it doesn't, it's literal. It's literal.
Oh, yeah. It doesn't in the order that it's happening on the screen. So what I can do to fix this is I can say, what I need you to do is I need you to lowercase it, truncate it first, and then finally wrap whatever's left inside of quotes. Now this will actually work, and we're going to end up with hello being in quotes.
Oh, wow. That's really cool.
Yeah, that's one of the things you got to be careful of. So if you're stringing together a lot of functions and all of a sudden your chart starts breaking, think about what is each one of these things, because this is just a pipeline. We're saying take the raw message 1 and give it to lower. And lower says, great, I'm going to lowercase all the letters. Great. Then I handed it a moment ago to quote, and quote says, great, I'll put quotes around it for you. And then truncate says, well, I'm going to cut off the last, I'm only going to give you 5 characters, which meant the closing quote got lost. So make sure you think about the order that you're applying these particular functions in. Otherwise, you might get yourself in some trouble like I did when I put truncate in the wrong position. So I could have truncated it first and then lowered it. I mean, but truncate, you don't want it to be last and if you're using quote, because it actually could get you in trouble. So I threw that out there because whenever I get burned with something, I'm like, let me tell other people so that they don't get burned by the exact same thing that I did.
Makes a ton of sense, Donovan.
Cool. So we're going to go a little bit further. Now, you can do more than just sending this stuff to other functions, and you can do if statements and for loops. It's basically it's a programming language. I think it's the Go scripting language is what we're using here. Now, what I've also noticed is we've only used 3 functions here, but if I were to do 5 or 6 functions, this would get really long and start to get really intimidating because I'm like, I don't want to read all this, and this file starts to get really scary. So what you can do instead is you can create your own named functions. Just like you have lower, I could write my own and use that in place. And then inside my function, do these 3 or 4 things so that now all of a sudden my chart isn't so scary. So what we're going to do is a couple things. I'm going to replace this with what I'm going to build, and then I'll build for you what it is I'm going to do. So what I'm saying is that I'm going to write a template called lower trunk, which will lowercase and truncate a string. And remember that dot is the object. It's an object inside of Helm. And I'm saying, and I want you to pass that main object to my function, which means I'll have access to dot values and I'll have access to dot release and some of the other built-in objects, right? So that's great.
So is this like an include, if you will?
Sort of. Like this right here is when I'm saying template, I'm more of a saying, hey, I want you to go ahead and call this function called lower trunk, and I want you to pass it my main object. Because there actually is an include as well, besides just template. So that's why I don't want to say it's exactly like an include, because there actually is an include keyword as well that we can talk about if time permits. But what I want to do first is show you where I'm going to write this particular function that doesn't exist today. So what I'm going to do is I'm going to create a file called _helpers.tpl. The underscore being at the front is important because I'm putting it inside of the templates folder. And because it starts with an underscore, when I actually install this, Helm will say, hey, it's an underscore. That's not for me to process. That's actually not a template. So I won't go in and try to change things. But this is a place for me as a template designer to go put helper functions and functions like the one that we had just written a moment ago inside of this particular file. So let's go ahead and open that. And let's go ahead and define the template. So what I'm doing here is I am defining a template. I'm saying I'm defining something called lower trunk. And inside of it, because I've passed in the dot, I'm going to say dot values message 1. I want you to lowercase it, and I want you to truncate it to 7 characters. And then I end it. So this is the way you define something, is with a define and an end. And then you can put all of the different Go scripting languages, if statements, and all kinds of stuff in between those brackets. And that will happen for you on whatever area that you use this particular template inside of your chart. All right. So if we go ahead and save this and I run this again, what we should see is that my hello W. And the way that we got that is we passed in this particular object. We then said, get me message values, message 1, lowercase it and truncate it to 7 characters, with left us with this, which is great. So I'm going to show you something that I haven't shared with people before, and it's actually not even in the video that you shared from YouTube. This is something that I learned after I recorded that video. That's pretty impressive, because if I wanted...
And AzureFunBytes exclusive.
Exactly. I haven't shared this with anyone, but this is something that when the light came on, I'm like, oh, now I'm really starting to get the power of these templates here. Because if I wanted to lowercase and truncate to 7 message 2 and message 3, I basically have to copy and paste this and have a version for message 1, a version for message 2, and a version for message 3. That's just going to be a maintenance nightmare. If I was writing C#, I wouldn't do that. What I'd want to be able to do is pass in the actual item that I want to manipulate, then have these things applied to it. And we got to go back and again break down what we're doing here. We're saying I have a template, name lower trunk, and I want you to pass it the default object. Well, that's really not what we want. What we really want to do here is pass it in the different value here. So what we want is to say value 1, right? Message 1. And now if I were to take this, let's just do to here. And then what I'm going to do is just copy that to here. I'm basically saying now instead of passing in the main object, I want you to pass in a specific property, message 1, message 2, and message 3. Now this won't work the way it is written right now. What we need to do is go back to our helper and explain to it, you're no longer getting the dot object, you're getting a specific message. So all we have to do is remove this. So dot in the context of this named template is what I passed in here, which is actually the message that I want to manipulate. So dot doesn't always mean the same thing everywhere. So now if I did this correctly and I run this, everything should be lowercase truncated. See?
Very cool.
But I didn't have to write 3 different copies of this thing. I just had to understand that I can pass in the specific thing that I want to manipulate into my template and then use dot as a reference to what I passed in. So granted, if message 1 had other stuff off of it, like different properties, I would be able to access those like dot and then whatever the property was off of message 1. Because message 1 might be an object inside of my values file. It could be an array inside of my values file. It might not just be a literal string like it is in our example. But what you're doing is saying inside of my template, dot references whatever I'm passing in on the right-hand side. And that's very important to understand. And this really allows us to reuse lower trunk for multiple instances, which is kind of cool.
Very cool. I dig it. I love less is more. You know what I mean?
Exactly.
That's why these tools always really help everyone, because you're offering them to be able to do more by writing less like complementary code or writing less YAML. I know I've heard from people like Bruno Borges, who's not the biggest YAML fan, and some people who, when they're stuck using YAML in certain situations, they want to be able to simplify it so that it's not getting unwieldy and needing its own linting process, which it does, its own testing, which it does. So you might want to just minimize the number of tests you're going to have to write. And so that leads me into a question that I have. Is there like a testing suite that you work with, or are you basically just setting up kind of unit tests about, X happen, if Y is the response, then the test passed?
Great. So what I will do is I will answer that, but I'll answer it because what I'm going to do is I'm going to go through one more example, and then I'm going to show you the default chart. The default chart actually has a test file in it, but it's not a unit test like you're thinking. What you would do is you would then deploy your chart into an environment and then use the test to verify that it deployed correctly.
Very cool.
I would define it more like an integration test, right? Okay. A test is where you can mock things out and nothing really happens, but you're able to test the logic. This is more of an integration test where you say, I have now deployed the environment, deployed my chart into Kubernetes, and I want a way to verify that everything landed the way that it was supposed to land. That's how the tests are used inside of this. And there's a Helm test command that you'll be able to use.
Very cool. And just so everyone knows, the that video on semantic versioning, I was able to get that up. It is here on the Learn TV page. If you want to get more information there, or of course check the show notes.
And you were talking about YAML, and one of the things that I would tell you to go find real quick too is right next to that video should have been one on YAML, because I completely agree with you on how painful YAML can be at times. And I was just like everyone else. I was upset that YAML even exists. I'm like, why don't we just use JSON? JSON's very forgiving. It's easy to write. Spacing doesn't mean anything. YAML's really upsetting me because you get one space out of place and everything breaks. It was just a nightmare, right? You can't use tabs. You had to use spaces. And I used to hate YAML. But so what I did is I went down this rabbit hole about a month ago. And I said to myself, Donovan, stop being that person. That guy that just hates the change and refuses to accept it because it's different. Don't be that guy. Go understand why YAML exists. Go understand the problems that YAML was invented to solve, and go see why YAML isn't JSON. Because we already had JSON, but we created something else. Why did we do that? And I created a video, the 10 things you probably don't know about YAML, which completely changed my opinion of the language. And it actually is more of a language than it is just a text format, because they have anchors that you can use to replace inside of your files. You can actually, and in version 1.2 of YAML is 100% backwards compatible with JSON. So if you really wanted to use JSON and you know that the tool that you're using is a 1.2 version YAML, you can literally just give it JSON and it'll work. And a lot of people don't know that, right? So this is the same kind of approach I'm taking with Helm. Is like, I want to understand and learn this thing and stop using it and being mad that it's not what I thought it was supposed to be. So go out there.
Great way to think about it. Don't get mad. Can't even understand it.
Exactly, because there are a lot of differences between YAML and JSON, and that make it a far more powerful and impactful way to articulate the data that you want. But if you're in a pinch, you can still use it, and you can actually interleave JSON and YAML in a YAML file, right? So if there's parts that are just easier for you to show as JSON, you can just drop the JSON right in your YAML file. And if they're 1.2 version parser, it'll just parse and work, right? So yeah, don't hate on YAML until you really understand like why it's here and what it's to solve, and stop being that that person who's just like, it's not XML, so I don't care. XML was the greatest thing and we should just still be using it. You know who I'm talking about. So so let's just go and understand why JSON exists. Why does YAML exist? And what problems are they here to solve? And I think it'll change the way that you look at all these charts going forward, because it actually helped me a lot. So that's another good video you can find on my channel on why YAML and why it's here and what it does for us.
Sure. I'm going to actually post it right now. 10 things you don't know about YAML.
Cool.
That's the great thing about this show. When we do things, we try to get them to you as quickly as humanly possible so that you can take them with you after the show. So it's in the chats. It's in the show notes, of course, when the show's finished. You'll be able to get all that information about 10 things you don't know about YAML.
Cool. So there's one last file that I want to talk to you about, and this was the scariest file I'd ever seen inside of a chart before, and it's called the notes file. And I remember I opened a chart, I saw the notes file, and I just deleted it off my hard drive because I thought I'd downloaded a virus or something. Like, this can't be right. This is very, very scary. But when you understand what it does and you understand the templating, then you're like, oh, okay, now I get what this file does. So let's go ahead and create one. And then what I'm going to do is I'm going to go ahead and open the notes file here real quick. And what we're going to do is we're going to populate the notes file with some information. And as I'm typing this, right, so it says you can put anything that you want in the notes file, and it will be shown to the user after they install your particular chart. And then they can even ask for the notes alone. So they can say, hey, I've already installed it. I didn't pay attention to the notes. Can you please go show me the notes of that particular chart that I installed again? And it'll dump out the notes for that person. And as you can see, you can use the same templates that we created a moment ago. You can actually use the same values that you used before and build a really compelling instructions or notes or tips to the person who just installed your chart. And if you go back down and you install this chart again, what you're going to notice down at the bottom is that we now can see that we have a notes section.
Mm-hmm.
And as you can see also, the hello world was fixed in both places. One of them's truncated in lowercase because it used our lower trunk template. The other one is just the plain text, which came from over here as well. So it's really nice to be able to say that I can build a really compelling message. And you can do really cool stuff in here. One of the demos that I did for Dapper is a Twitter sentiment analysis. And to deploy it into Kubernetes, into AKS, I actually use a Helm chart. And what I'm able to do in the Helm chart is realize, is the person running from Mac or Linux or Windows? Because the notes that I dump are different. Because what I want to do is give you a command that you can just copy and paste into your shell of choice. And if you're on Windows, I give you a PowerShell command, which has slashes and line continuation, which is different than Bash, right? So if I realize that you're on Linux or Mac using a Helm chart, I'm able to give you custom notes just for what it is that what platform that you're on actually on. So the notes file is actually quite powerful once you start to combine it with the ability to use Go scripting languages and the token replacement that we're talking about to build a customized message for each person who installs your particular chart, which is kind of cool.
That's awesome. So we got a question, unless you are you in the, still kind of showing?
No, go ahead.
And so this one comes via Learn TV. Of course, we got less than 15 minutes left. We got about 5. And Wout asks, is it required to get to know Kubernetes and Docker before getting started with Helm? I'm going to probably guess yes, but I'll let you give that an answer, Tom.
I think if you really learn Helm, it'll mitigate some of what you have to know about Kubernetes. Because if you notice, I haven't used a single kubectl command, right? Everything I've done is inside of Helm. I can install and uninstall without ever going and learning all the different kubectl commands. So I think if you're lucky enough that you're going to be able to install everything that you need through Helm, you might be able to sidestep a little bit, but you're going to need that, right? To me, kubectl is that lower level tool that you're going to need to be able to do some diagnostics. Because if your Helm chart doesn't install the way that you want to, and you want to go see if everything and manually verify without using a test, if everything landed where it was, that's when you drop down to kubectl and you start running commands to look at what pods are running, what did my config map get in there, were my secrets stored correctly. That's how I go and I troubleshoot. So it might mitigate it a little bit, but you're going to have to learn it. Right now, we're working our best, though, trust me, on the incubations team to try to abstract you away, as far away from Kubernetes as we can get you, and still allow you to leverage the power of Kubernetes, but never know what a pod is, never know what a node cluster, we don't want you to know any of that stuff. We want you to leverage the power without being distracted by how difficult it is to manage Kubernetes. Even with managed services, Kubernetes is still a pretty intimidating piece of software. and it's really operations focused. So for a developer like myself, it's really scary.
Yeah.
To talk about ingress controllers and all that kind of stuff. It's just like, oh, I don't want to know anything about that. Just please get my container to run, right? And what we're trying to do is get to that place to where a developer only focuses on delivering their value, and the rest of that stuff is taken care of for you. And I think Helm gets you a little bit there, but I think you're right too, Jay. You're going to have to understand what an image is, how you build an image, how you push an image to a registry. That way you can then download that image into Kubernetes and actually run it inside of a container. So, and if you didn't know what some of those words were that I just said, like container registry and image and container, even using Helm is going to be scary, because that's basically what you're doing inside of Helm charts, is deploying images inside of containers that are being pulled from registries, right? So you kind of need to understand those fundamental things.
And that leads me to this link right here that I think you all should take a look at. That's really important, is that you can eventually store these charts or images in an ACR, an Azure Container Registry. So a place to kind of put your stuff, if you will, a locker, to keep things under lock and key so not everybody can get to them in the public world. And so you're still going to have to understand the push-pull aspects of it. You're going to also have to understand the IAM aspects of being able to set the correct security permissions to be able to allow access to these charts, things like that, other than just storing them locally on your computer. So Donovan, we've got about a little less than 4 minutes left. And so I'll let you, if you want to show one last thing, if you want to do one last thing, and then I think after that we'll review our poll and close.
All right, cool. So one last thing is I deleted everything that I had just done, and I created the sample template. And as you can see, this is a value.yamls file, but it's far more complicated than what I showed you. Just to give you an idea of the potential of what you can store in one of these files. You can have nested objects with different properties. You can have arrays and collections inside of here. And if we were to go back in and look at that notes file I was talking about, when you see this for the very first time, it's like, I have no idea what this thing is doing or why it exists, and I closed it and I ran away. But now we understand that we're able to use Go logic for if statements. We're able to range over collections and arrays. We're able to then use those replacements that we're talking about. So this file is far less scary than it used to be. And then again, when you look at a deployment, everywhere that we have the word values is something that we're now able to replace from the outside in using those templates and things that we talked about before. So once you understand what all those bits and pieces are, these files are no longer as scary as they were before. But it took me going to an empty folder and building this stuff file by file, character by character myself, before now I can download any chart and say, yeah, I understand how that chart works, and I can make changes to it if I need to. So that's all I wanted to put up, is put a bow on this. Shouldn't be scary anymore. But can you imagine if this was the first thing you saw trying to learn Helm? I freaked out every time I saw it.
I'm sure. So, hey, and if you want to see Helm for the first time, you should go check out helm.sh. Here's our poll. Are you using Helm charts to deploy your packages? We got a 40 to 40 on yes or no. And then, of course, it's complicated because not everything is cut and dry. When it comes to the cloud, sometimes things get a little complicated. But Donovan, you helped us remove some of that complication out of this. And I really, really appreciate it. I had a great time talking with you. I always do. But I love watching you nerd out on something that you're really passionate about. It's a lot of fun for someone like me to see. And I'm sure it's also great for our viewers.
Cool, man. No, thanks for having me. I am so proud of you, man. Not only what you've done with yourself, but what you've done with the show. So just keep it up. Anytime you want me back, you just let me know.
Absolutely. And don't worry, I will take you up on that. So everybody, we're going to give you all a great big goodbye. Next week, make sure you stick around and watch the show. We're going to have one of the creators, one of the original founders of Kubernetes, Brendan Burns.
Nice.
He's going to be on here next week, and we're going to be able to ask him those big questions about how Kubernetes started and how it's currently advancing and what things you can learn about it. So from myself and Donovan, we'll see you again soon. Thank you very much for watching. Always appreciate it. Thanks, Donovan.
Take care, guys.